Hi everybody, this is my first video on the channel and I want to take just a quick moment to explain what's going on with the video that you're seeing now and the ones that you might be seeing in the future, and then I'm going to get into a lesson on this first chapter here, so feel free to skip ahead if you so desire. But basically, I'm someone who recently came out of a master's degree program primarily studying machine learning, AI, deep learning, all that good stuff. And after coming out of it, I really don't feel like I retained a lot of the information. Those of you who have studied machine learning in school or on your own self study will understand that this is a lot of information. It requires a lot of background knowledge from anything from statistics to linear algebra to computer science. And that's all you need just to get started with machine learning, right? And like I said, I didn't really come out of school knowing enough to apply it, go forward, get a job in it, work on a side project or startup in it. And I want to correct that because, I did a whole master's degree on this and I want to get my value out of it. And I think the type of way I learn is by getting exposed to something and then taking some time away from it and then coming back to it and then really drilling it. And I think I'm in that drilling phase right now where I can look at machine learning content and sort of rationalize and understand it and maybe create my own thoughts based off of it. So we're going to try something out here. I found this nice book online right here called Introduction to Machine Learning with Python, a guide for data scientists. And what attracted me to this book is that they try to do a top-down approach instead of a bottom-up, right? In the classes I took in school, they really began with a lot of the concrete hard math aspect of machine learning, like how to do a classification from scratch without even touching a computer. And while that's not a bad way to learn it, it really just did not work out for me. And I think that's why I missed a lot of the concepts and kind of have another go around with this. But this book does it differently, where they actually start from the computer science aspect, the application aspect, and show you the examples. I just went through chapter 1 here. In the first example, they talk about classifying different species of a flower, and they just get right into the code. They show you what Python libraries that you need to import and kind of how to get started right away. As in, you could copy and paste the code and actually have your own classifier just from looking at chapter 1, which I think is really attractive, really enticing for this type of content. And so I thought, I could use this video platform as a way of getting inspired by going through these chapters. I'm not really great with reading books, especially technical books, but we're going to just try something out here and get inspired by this and kind of start vlogging my progress through these chapters. So like I said, I just finished chapter 1 and I'm going to give you the high level overview of what I learned. I won't go into super detail. This is, this probably won't replace reading the book itself, but maybe the high level concepts and perhaps just my general me communicating my understanding and maybe little bit of my own thoughts might even help you out. But I know it'll definitely help me make sure I remember and retain what I'm reading. So here's my short synopsis on chapter 1. These are really just rough notes, and I'll just expand upon them briefly, try to keep this short and to the point. So chapter 1 is really an introduction to machine learning. It talks about why you might be interested in it, what you can use machine learning to do in terms of using it as a tool. Chapter 1 gives a couple examples saying, a bank wants to be able to determine and detect when a fraudulent transaction takes place, right? A cancer patient wants to have the best treatments that would work best for their body, their height, weight, family history, blood type, all those types of things. So thus is some inspiration, some motivation for machine learning. And the first major concept that this book goes into is supervised learning versus unsupervised learning. And if you aren't familiar with what those mean, basically, supervised learning means that you know what your data should be classified as, and unsupervised learning means that you don't quite know what the we'll call them labels for your data are. So to give an example, let's say I have a classroom full of students, right? I just say I have students. I'm not telling you if they're young or old or college or middle school students. There's just a bunch of students, right? The label, if we talk in terms of supervised learning, means that I will tell you that there is a classroom full of students, and you will know what grade every student is in. They might be a first grader, they might be a 10th grader, third grader, whatever. Unsupervised learning, if we can, I'm also trialing out this iPad here, so we're going to learn a lot of things along the way here. If we're talking about that same problem in terms of unsupervised learning, it's like I tell you there's a bunch of students in the classroom, and I might tell you, this student's favorite food is this student's favorite subject is this, their favorite class is this, and you have to use that information to decide, are they a second grader or are they an eighth grader? Maybe they're a college junior. So that's what unsupervised learning kind of means, is that you have information on your problem, but you have to determine how to classify those people, right? The supervised learning part, the difference in how you would use these practices, it's, let's say for supervised learning, revisiting this guy here, for supervised learning, you want to take the information of the students, your favorite flavor of ice cream, do you know how to ride a bike, and that will already be paired with, they are a second grader, they are a ninth grader, they are a 10th grader. And then you'd learn based off of that. That's where the term learning comes in. You'd learn based off of that. And so when I walk you to the next classroom over, a bunch of random strangers, different students, different qualities about them. You can use your learned model on these brand new students and say, oh, this is definitely a second grader. This is definitely a fourth grader. The unsupervised learning model is this: we're just stuck in this one classroom and no one's allowed to leave until I know what everyone's grade is, or approximate grade, since I'm taking a very, very educated guess on that. That's the difference between supervised learning and unsupervised learning. Now, on the bottom here, the next major topic that they go into is how do we organize this data? And you'll see I have this kind of looks like a rough spreadsheet where you have these X's on the side. Maybe it helps if I do a different color so you can distinguish between what I've written and what I'm talking about on here. I think that's over here. How about yellow? Yellow's nice. So you have this table here where you have these X's and you have these F's, right? X's are your data points. F's are what we call features. Those are very, very common, popular lingo in machine learning context if you're very brand new to this. And I won't go, like I said, I won't go in super detail on this, but X, you can think of X as those students in the classroom. You can think of F as different features of those students, like, can you ride a bike? Is chocolate your favorite color? What's your favorite subject? Do you like social studies or do you like embedded systems? Right, two very different things based off of how deep you are in your academic journey. And so this is how data is organized. This is student number one, student number two. You have chocolate here. You have, yes, I can ride a bike. My favorite class is history of art. And I go to bed at 4 o'clock in the morning. So you could probably tell that this is a college student. And you could make up more features for here. I think it's pretty straightforward. But let me know if it's not. Maybe I'll just remake the video if it turns out that this is extremely confusing already. Going on here, the next topic, knowing your task and data is of the more important aspects of building an ML solution. So this isn't really a technical topic here, but it's just saying that and if you have the opportunity to talk to full-time machine learning engineers, I think a lot of them will say this too. I'm not one, but this is what I've heard, is that a lot of your time building and developing a model, a machine learning algorithm, is making sure your data is as in a best shape that it can possibly be. Right? It's not so much about deciding what is this complex algorithm that I need to create, or how much time is it going to take for my model to train on this cluster of 13,000 computers. It's just making sure your data is in the right style, we'll call it. And I think that's really all you need to know at this stage of the book. The next 10 chapters will probably cover just enough information for you to understand exactly what that means. And practicing it too will help along the way. Down here, we have be mindful of the assumptions that you're making. That's another important thing to be mindful of, quite literally. And the essential idea there is that, we're given only so much data on the students, right? But we would assume all kinds of things. Like, I live in the United States, and typically children are in school from grades 1 to 12, right? But other countries, so once you graduate high school after grade 12 in the United States, you have the option of going on to college. And by then, people are generally around 18 years old, whereas different countries, I don't know any specific ones, but different countries might have students graduating from high school, the equivalent level of education, at 16 years old, 2 years younger than the average American high school student. And so when I give you this information about the students, your favorite color of ice cream, do you know how to ride a bike? You might use that information on American students and get a pretty good model. But if you use it on students from a different country, you don't really have as good of a model as you could, because you're making assumptions that these students are from the United States, right? So that's an example of assumptions that you could be making in your model, something you might be completely oblivious to. You have no clue. And so thinking about that while you're working with your data and building your model is very, very important. Okay, so what other notes did I take here? Yeah, I didn't really organize this at all, but I'm just going to talk about it. Hopefully it helps me and maybe helps you too. This IRIS data set got going on here. I really hope my mic is on too. This IRIS data set, this is the beginning example that the book gave. Like I said earlier, is an example of classifying different species of iris, which is a flower. And these are zoom in here, these are the species of flowers: Setosa, versicolor, and virginica. I think that's how that's pronounced. There are 3 species of the same flower. And these are the 4 features associated with every flower. So you can imagine a data set. Let's say it has 150 flowers, right? And every one of those flowers can be one of these 3 species. And we have to build a machine learning model to determine, flower number 4 is probably a Setosa, right? I'm not going to go through building the model. There's plenty of examples on there online, and if it's requested, maybe I'll even do a quick demo, but not for this video. But let's say that again, flower 4 might be versicolor. We can determine that by using the data points, which include the sepal length, sepal width, and petal length and petal width. I forget what a sepal is, but just know it's just something that has to do with a flower. That's really all there is to it. Okay, and what do I have next here? Yeah, so that's more general stuff. So yeah, if you could just conceptualize, don't even dig into the technical details, but there are a bunch of flowers, a bunch of data points that we need to find out, are they this kind of flower, that kind of flower, or this kind of flower? And we can determine that. We can build a model to figure that out by looking at these features. Simple, right? Moving on now. A model can overfit to training data. Okay, we kind of skipped a couple steps, but here's the bridge. You will train a model. I give you 150 sample flowers where these are known to you, the human, but not to the computer. We have to train the computer to have the confidence of picking the correct types of flowers. That's getting really messy. Let's see if we can clean that up just a tiny bit. Right. Okay, so you have a model that's trying to predict this, essentially, right? A problem that you can run into, and future chapters and videos will explain this better. A problem you could run into is that if I want to train my model based off of all my known data, I have all the data needed to tell what species these 150 flowers are. But if I train my model on just this data set, then my model will probably be really good at figuring out what these 150 flowers, what species they are, right? But Then when I go outside and pick up a new flower and show it to my model, it says, hey, here's a flower, model. Good job. The model might actually have a problem. We call it overfitting in machine learning lingo. At least I do. And the problem of overfitting is that the model knows your base data set so well, and I mean really, really, really well, such that it only knows how to classify data from this data set. And the moment you show it something brand new that it hasn't seen before, it panics. It's useless at that point. So yeah, your model can overfit to training data, right? What I should also say, and I think I talk about it right here, is that you have a training data set and you have a testing data set. This looks ridiculous. Those 150 flowers are from your training set. And that new flower I went outside to grab is from a test set, we'll call it for now. It's enough to understand what's going on here. You just need to know there's a difference between training and testing. And in order to avoid this overfitting problem, we can do this thing called We can do this thing called a train test split, where we take those 150 flowers and split them. And let's say we had 120 for training and 30 for testing. Okay, so instead of the model learning these species based off of all 150, we do our best to learn it off of 120. It's a little bit less data. The model might be a little less accurate, but keep with me here. It learns off of these 120, and then I use these 30 for testing the model. That means that these 30 flowers are data that the model has never seen before. I'm just holding it in my back pocket until the model has been trained off of these 120. And I can use these 30 to see, okay, can it guess half of them correctly? Can it guess all of them correctly? And depending on where that stands, anywhere from none of them to all of them predicted correctly, that will tell me the strength of my model. Because in machine learning terms, we judge our models based off of its ability to classify information it has never seen before. And that's the whole point of things. If you think about your email inbox where there's a spam filter, right? There's going to be new kinds of spam emails all the time. And so customers who have their email accounts will be satisfied if over time these brand new spam emails are still classified as spam, even though they've never been seen by a model before. Make sense? Awesome. Okay, now I think that's my last page here. So hopefully this video wasn't too long, but the notes here say evaluating a model. We make a general assessment of a model by comparing its output to the true label. Great. So that's kind of what I just talked about, but a little bit different. So its output compared to the true label, right? So remember this example with the flowers again. For this 150 data set, 150 flowers, I already know as a human which species each flower is. But the computer, the machine learning model, doesn't know what that is. And we teach it to learn that, okay? And when a model is learning, again, we're talking very, very high level general terms here. When a model is learning, it's going to have the ability to make some kind of prediction, right? It might be a correct prediction. It might even be a wrong prediction, but it's going to make a prediction. And while we know, what's the name of that flower again? Setosa, let's just say Setosa here. It's a fun name. Setosa was the correct label for flower number 1, right? But the model guessed Virginica, right? Here we go. Virginica, right? This is obviously the wrong prediction, right? So we as a human, or as a code developer, a software writer, we can put in code that says, oh, when you're finished predicting, check if it says Setosa, right? And then the model's going to say, oh, I got Virginica. No, that's not right. That's wrong, right? But our algorithm, the way the code works out, is that we'll say, okay, I understand she got the wrong answer here. Here's the right answer. And these are the features that you should have looked for to determine that it was a Setosa and not a Virginica, right? This conversation that we're having with our model happens through the code. But in a way, that is the learning process. We compare the output to the true label. The output was Virginica. The true label was Setosa. We make those comparisons, but just not for one flower, but rather 150 or 120 in this case here. And we do that a couple times. We iterate on it. We work at it. Spend a little bit of time on it, and eventually, you'll actually have a pretty good model that can determine what species of flower that you have. And so that's basically it for chapter 1. Again, this is not a replacement for reading the book, but this is a way for me to kind of make sure I'm understanding everything that I'm reading in this book. Hopefully that I keep with it and make it all the way through and become an amazing machine learning person one day. We'll see what happens. But if this video helped you out at all, feel free to let me know. If there's anything that you didn't like or something you'd like to see more of, then drop it in a comment, and perhaps as I go through this book in future machine learning examples, then maybe we can work together to make something special happen. Until then, I will be hoping to see you all around, and have a wonderful day.